Properties along British Columbia's Vancouver Island coastline command massive real estate premiums. The most desirable lots face the water, offering clear lines of sight across the Georgia Strait toward the jagged peaks of the coastal mountains. Acquiring these exact sightlines means positioning a home on the absolute edge of the continent. It forces a direct confrontation between ambitious architectural design and strict natural limits. The first obstacle is the ground itself. The coastal terrain features extreme side slopes, pitching downward at 70 to 90% grades, covered by a thin veneer of soil sitting over solid volcanic basalt. Before a single wall goes up, building codes dictate that residential foundations must rest on material capable of supporting at least 75 kilopascals of bearing pressure to safely absorb the structure's weight. Building directly on an unmitigated steep incline or on disturbed, loose soil invites severe settlement risks, causing a structure to physically shift as the earth compresses under the load. Likewise, if a foundation isn't dug deep enough below the frost line, freezing temperatures cause the ground to expand and heave, violently cracking the concrete above. Building on a 90% vertical drop of basalt shifts the project away from standard residential carpentry and into the realm of geostructural engineering. To create a level building pad in impenetrable volcanic basalt, crews must shatter the cliff face using controlled detonations. Engineers drill a concentrated grid, spacing holes 1.8 meters apart. Each meter gets 4.43 kilograms of explosives. On extreme drops, blasters drill short horizontal holes under 3.6 meters to prevent fly rock from spilling downslope. Because this occurs in residential areas, independent seismologists monitor peak particle velocity using continuous telemetry to ensure the shock waves don't crack the foundations of neighboring homes. Coastal blasting is a highly regulated sequence of events designed to precisely carve a stable building shelf into the face of the cliff. Even after the rock is cleared, the remaining surface is jagged and uneven. Engineers adapt to this incline using stepped footings, pouring concrete that cascades down the slope until it locks into undisturbed solid rock. On the tightest, steepest lots, traditional foundations aren't enough. The entire structural load must be transferred deep underground using micropiles. Crews use compact drilling rigs to drive a steel casing through topsoil and fractured rock into the bedrock below. A steel reinforcing bar is centered inside, and the cavity is pumped full of cement grout under extreme pressure. As the grout cures, it forms an inseparable bond with the bedrock, turning the home's foundation into a physical extension of the cliff. Beyond the stability of the rock, engineers account for heavy winter rains that saturate the local sandy loam, creating immense hydrostatic pressure against the concrete. Contractors must allocate an extra 10 to 15% of their budget, specifically for site drainage. Skipping this leads to a collapsed retaining wall after a single heavy wet season. To relieve pressure, crews install lines of perforated pipe along the foundation to channel water away. Pipes are carefully bedded in clean gravel, wrapped in landscape fabric to keep out silt. Steep terrain engineering requires moving rock, but keeping the structure standing requires giving thousands of gallons of water a safe path of least resistance. The chaos of explosives, drilling rigs, and mud eventually gives way to a refined luxury housing market. The upfront preparation is costly. Developers pay for specific municipal blasting permits, independent seismology reports, and $5 million liability insurance policies before pouring a single yard of concrete. But the resulting homes command heavy returns. Finished properties on these coastal cliffs frequently list between $1.6 and $3.6 million. The engineering itself generates revenue. By stepping the foundation down the steep incline, architects naturally create walkout lower levels, which are routinely converted into high-income legal secondary suites. The extreme slope dictates a structural necessity, which ultimately unlocks a lucrative long-term financial asset. The finished designs lean into their environment, featuring open concept layouts, floor-to-ceiling glass, and multiple decks looking outward over the ocean. This sense of serenity depends on the high-performance systems buried beneath the floors, the micropiles, the stepped footings, and the active bedrock drainage. These homes prove that with precise engineering and deep geotechnical planning, we can safely and elegantly anchor ourselves to the very edge of the continent.